So thank everybody for coming. It's pretty cool to see a bunch of people getting together to talk about MERB. Today I'm going to talk a little bit about MERB, then and now, right? So,
If you could please pull the mic up a little closer to you.
yep. So MERB started September 21st, 2006. Which was actually the same month we took our first customers on Engine Yard. And this was it. There's a historic pasty that you can still go see. That was like the first pasty of MERB that I showed anybody. So there it was. It's come quite a ways since then. Now we've got quite a stack going. Number of different components, and I really like the way the architecture is played out. It does allow you to get up and going pretty quickly, but it also allows a great deal of flexibility with the architecture of your applications, right? We're not locking you into any certain way of doing things. We're very agnostic about backends, JavaScript, this and that, but we are working on a stack that will make everything a lot simpler to get up and running with. But I think the real place where MERB shines is in the last 20% of the 80-20 rule. As we all know, Rails really shines at the 80% of the 80-20 rule, right? It'll get you 80% of the way there pretty much faster than any other framework on the planet that I know of. But when you need that other 20% that it wasn't designed for, you're going to be fighting with it tooth and nails, and you're going to have a bad day. So I want to go over what I consider to be the core tenets of MERB and what drives the development of the framework and what the goals are, just to be very clear. So first of all, MERB should be fast, and I'm going to list these as a bunch of specifications with should, right? So no code is faster than no code has kind of been MERB's model. And this is especially true in Ruby, which is a very dynamic language, but as everybody knows, the runtime is a little bit ancient. And it's a tree walker, so it doesn't do bytecode compilation. Matches Ruby anyway. So it's always constantly walking around this abstract syntax tree of your code, executing things. And there's a lot of overhead in that. So what I found with Ruby is the least amount of code you can express something in is going to be faster, just because there's less tree walking to do. It also makes things a lot more memory efficient. So we spent a lot of time in the MERB code base. Some people would say we're premature optimizers, we're micro-optimizers, this and that. But the thing is, especially in Ruby, when you build a big web framework, micro-optimizations count because they stack on top of each other. That's why MERB is so efficient, and that's why it's such a nice runtime environment, because we have focused on every little detail, done extensive benchmarking, try to keep things as fast as possible without making the code unclear, because some optimizations can make things really unclear. But Ruby is a very expressive language, and it will allow yourself to shoot yourself in the foot if you're not careful. And, a framework is a foundation. So you want your foundation to be solid and simple, and you want it to be, you want the framework to have the least amount of overhead as possible, so that you can have the overhead in your own code, right? Every bit of code that the framework takes away, every bit of efficiency the framework takes away from you is less efficiency you have to build with your own app. Are they? So talk louder. Okay. So MERB should also be memory efficient. I've run hundreds and hundreds of Rails applications in production, and it's really not memory efficient. Average Mongrel size is 100 megs, and I've seen them range from 50 megs to a couple gigs in some cases. And especially in Ruby, current Ruby, where the garbage collector is fairly weak, keeping the amount of memory you use down is a huge advantage. The more memory you use in a Ruby process, the more objects there are that the garbage collector has to walk every time it garbage collects, the more CPU and wall clock time is going to be taken away from your code by the garbage collector. And I've seen some really leaky applications that, trying to debug them using strace and all these other kind of things, you end up seeing that the processes are actually spending the majority of their time, like 80% of their time, in the garbage collector because they've grown to hundreds and hundreds of megs and there's millions and billions of objects. So we try to create as few objects as possible to get the job done. Try to load as little code as possible to get the job done. Most of MERB is loaded with kernel auto load so that a class won't actually be loaded until you actually reference it. And we try to be lazy with a number of other things as well, session instantiation, a bunch of stuff. So try to be as lazy as possible. If you don't need an object and you haven't allocated it, you win, right? If you need to allocate it, then we'll allocate it then. So this has paid big dividends. You can, especially with Fabian's work on mini gems, Ruby Gems itself does some kind of crazy stuff. When you boot up an app, it actually loads the index of all the Ruby gems in your system. And that can take a lot of memory. And it only does that so it can find which gem to require, right? And so the more gems you have installed on your system, the more memory your processes are going to take. So Fabian wrote mini gems, which bypasses the standard Ruby Gems loader. So it doesn't load all the indexes to do a search. It basically goes out of its way to try really hard to not load the Ruby Gems indexes. So this gives us a huge advantage. On my Mac, I have maybe 100 gems installed or something. And using standard Ruby gems, loading a brand new MERB core app with maybe 5 controllers and a bunch of views and data mapper, we're talking about 32 megs of RAM. When you use mini gems instead, it brings it down to 20 megs flat. So that's really sweet. You can get 5 MERB processes in 100 megs, which is what you get 1 Rails process in. And each MERB process can handle 2 or 3 times the requests a Rails process can. So we're getting massive efficiency gains and saving you all money on servers, which is good and bad for me, right? But it's good. I hope MERB can help put to bed the FUD that Ruby doesn't scale and that it's bloated and that it's not fast, because Ruby is fast. You just have to know how to use it and get to know all the quirks, which there are thousands of quirks. So we spent a lot of time learning those quirks and figuring out the best workarounds to not invoke those and to not have side effects from those. So yeah, memory. This is another big one. The core code should be as simple as possible. I don't want any sausage frameworks here, right, where you don't want to know how it's made. I want people to be able to, they're writing their apps. I don't want them to be afraid when they hit a bug to go into the framework code and say, oh, well, what's going on here? I don't want the framework to be a black box. I want it to be open and simple so you can go in there and say, oh, well, that's what's going on. That's easy to fix. Let's just fix it. So, you're building these applications, and if you're not familiar with the framework and if you're afraid of going in there, you've got this giant black box of code in your app that you don't know what's going on in there, and you don't want to look because it might be ugly. And that just doesn't make sense to me, right? I'd rather have code that you can go in and just say, oh, this is very simple. We're not doing crazy metaprogramming backflips, if possible. And I think that's a huge advantage of MERB, is that the average person that's just writing web apps isn't going to run away screaming when they go and look in the framework code. So MERB should be modular, which you saw the list of gems. Some people, it is a lot of gems when you install MERB. You're like, oh damn, there's 8 million gems that just installed. But it's not that bad. You can just gem install MERB and you'll get them all. And we're working on a MERB stack. Yehuda and the other guys have been working on it that will tie together MERB and data mapper and jQuery and some other stuff to give you this out-of-the-box, full-stack experience like you can get with Rails. But that is all underpinned by our modular architecture, so you can remove pieces, you can add pieces, you can use MERB slices, all this kind of stuff to assemble your applications. So we'll get you jump-started quickly out of the box, just like Rails, but we're going to be much more flexible when you hit the wall and you want to do something that we didn't anticipate with the framework, or you're working on some kind of new technology that nobody else has integrated. So we'll allow you to do that. MERB should be easy to grok and extend. I guess I kind of covered this one already, but it's worth repeating. There's nothing like having a production bug and it's not in your app, it's in the framework, and now you got to go spelunking and you can't figure it out because each method is a list of calls to other methods, and each one of those is a list of calls to other methods, and each one of those is a list of calls to other methods that alias themselves and then do backflips to come back up the stack, and you're like, what the hell is going on here? So yeah, I mean, code can just be straightforward and simple, and that's one of the things we're trying to prove here. So MERB should focus on the application server as well as the web framework code. I feel like Rails hasn't cared enough about that, and that is a big reason why it's so memory and CPU inefficient. This is a web framework, and yeah, it's important to have a nice API for you guys developing applications, but you need a rock-solid application server to run underneath you. So that's why we've adopted Rack, so we're abstracted from the actual web server it runs on. And lately, Yehuda has done a bunch of killer work on making MERB application server more of an app server, where it forks children, manages them, gives you some really cool stuff for fast deploys. Like with standard Mongrel and with Rails, you might have your application running, and when you deploy and you need to restart, you basically have to take all the mongrels down, wait till they unbind the port, and then boot your new ones up. Because if you try to boot your new ones up and they try to bind to the port, they'll crash because the port's already bound. So you have this big time gap of downtime, right, while you're trying to deploy. So with the new MERB application server, you can have your cluster of MERB processes running, and now it's time to do a deploy. So you deploy your code, you start up new MERB processes, they come up and they say, hey, I can't bind to that port, I'll just sit around and wait and try binding to the port. And then you kill your currently production processes, and the new ones just take over instantly. So there's this really minimized window of downtime when you need to do a deploy, and that makes a huge difference for doing fast deploys. And in development mode, you will fork a child of your process, and when you change any files, instead of trying to do crazy reloading like we used to do, or like Rails does, which a lot of times can get confused because it's not a clean slate. It's like you still have this old state, but now you're trying to map the new state in, so you have to like remove constants and juggle stuff and try and put it back together. That doesn't always work 100% properly. So what we've done, what Yehuda has done, instead is, we have a master process, we fork a child. The child is what runs your code, and when you touch a file or you change a template or you change a controller or whatever, it will just kill that child and the master will bring it right back up. So you get a completely clean state, completely clean slate to work with your new application code, and it's still fast because the master process has all of MERB and your gems and all that stuff already loaded, so the fork happens very quickly and reloads your application code. So this combination of features, I think, is pretty killer. It makes MERB much of a more focused on the application server platform. And we have more plans for the future, possibly including making the master process be a web server and a proxy, and have the workers not actually serve static files, but just pass them a rack environment over a marshaled pipe and have them serve the request and bring it back. So that would give you, you boot your master process and any number of children, and you have a cluster, and you only have to balance it from one place. Dynamic spawning, right? We could say, I want to run 2 to 6 MERBs, right? And the front end could say, okay, well, let's start with 2. Oh, now those 2 are getting overloaded. Let's boot up another 1 or 2, and then let's get rid of them later. That's future direction I think we might go in. So MERB should get the heck out of your way and be flexible. Opinions are great as long as they can be overridden. When you have too many opinions and you can't override them, or it's a real difficult path to do that, you're not going to end up doing it as often, and so you're going to have to conform to the way the framework was written. I don't presume to know what you guys want to do, so I don't want to force my opinions on you. We'll give you a way of using my opinions as a stack, but I'd rather you make up your own mind and figure out what you want to do with MERB. So it's got to be very flexible and dynamic, because, you know, there's relational databases. It's what everybody uses pretty much still, but those are not they're not the future, right? They're not horizontally scalable. They're just like this big central point of failure, right? Like a typical MERB or Rails app is completely shared nothing. You've got all these processes. You can scale the app servers horizontally as far as you ever want, but you've got this big, stinky, you know, lurker troll of a database that you can only pretty much scale up or add a bunch of slaves or whatever, but it's still this, you know, central point of failure. And with, you know, like Amazon Web Services and all this cloud computing stuff that's going on, you can spin up as many servers as you want, but that's not going to help you if you can only have one gigantor database server. What happens when that thing goes down? You know, your whole app is toast. So that's a big part of the reason why I made MERB not tied to an ORM, because there's all these new backends, CouchDB, SimpleDB, you know, Google's thing if they ever release it, and there's tons of people working on all this stuff, you know, and I just see a lot of promise there, and I think MERB's a great experimentation ground for trying out these new kinds of backends and these new scalable architectures. Oh, I guess I got ahead of myself. Anyway, so MERB should be an experimentation ground, right? Rails, you know, we owe a lot to Rails with MERB. You know, we've copied a lot of stuff from them. They introduced a lot of best practices, and they were really pioneering, and they were very successful. But with that success has come some baggage where, you know, there's thousands and thousands of people using Rails as a framework and running their production apps. And it's really hard to make sweeping changes to the framework without pissing off a lot of people. So that's a double-edged sword. It's great to have success and have so many users and become such a popular, you know, a framework that's just pioneered so many techniques, but it also saddles it with baggage that makes it much harder to experiment with different ideas. So I see MERB as a great experimentation ground for Rails. You know, there's a lot of stuff we do in MERB that can be applied back to Rails. We're a much more flexible platform for trying out these new technologies, mashing together different web services, different backends, different JavaScript libraries, all this stuff, so we can kind of shake out and see what's best out there and hopefully apply some of that back to Rails as well. But so, you know, it leads into our next point here. I get asked this question like all the time, right? Why didn't you just do this on Rails? Why didn't you just work on Rails? And, you know, the truth is I have worked on Rails quite a bit, and I've contributed quite a bit of stuff back to there. But it doesn't lead itself to experimentation. There's 80,000 lines of code, and there's a lot of, you know, you never know when you change one thing whose app it's going to break. And so that's just very constraining. So I decided to build. Well, originally I built MERB just to be, it was a fun little project, right? I wanted to do file uploads outside of Rails, render some little ERB templates and whatnot. And then as I started working on it, I was like, oh man, this is kind of fun. Just work on it here and there, and it just kind of has grown into its own thing. And so I see it as a chance to take all the good stuff that Rails has taught us and do a bunch of experimentation to see what we can make better and what we can do going forward for the future. One of the big reasons for this is I think monoculture is bad. People say, why'd you fork the community? And I'm like, well, monoculture is bad. I don't think that, you know, it's great to have one framework to rule them all, but it's also stifling. And it also, if there's only one big framework and there's no competition, then there's no innovation. People can just rest on their laurels and say, hey, I'm Rails, I'm it, right? So everyone wins when there's competition. You know, all the users of these frameworks win when there's competition between MERB and Rails. And I don't mean competition in like, my framework can beat up your framework. I mean competition in, here, we're innovating these features, oh, well, Rails can do that too, and then we're doing this, and then Rails is doing that, so oh, let's do that. And it pushes the bar higher and higher. And it's just all the users win. There's no doubt about it. So Ruby has kind of crossed the chasm, I think. It's, Rails is responsible for that. It really brought Ruby to light. But a lot of people have come for the Rails and stayed for the Ruby. Whoops. So I don't see it as a bad thing having multiple choices. I just can't see that being a bad thing. So lots of the merge lessons can be applied back to Rails. We've already contributed back a bunch of rack machinery. Yehuda increased the speed of their inflector like 10x, a bunch of other stuff. And I think there's quite a few things that Rails could take back from MERB as well. Just requires a little bit of work. MERB 1.0 RC is going to drop tomorrow. We're not actually going to release 1.0 because we've been so fast and furious on making all these changes, getting all bugs fixed, working with people that are new to MERB to have them try it out and see what breaks when they're first installing, all this stuff. So it's been a lot of rapid development, even up to even today. So releasing 1.0 today would be a little unresponsible. So we're going to release 1.0 RC tomorrow and let it gel for a few weeks and then release the big 1.0. So I'd really appreciate everybody's help in testing the hell out of this RC, telling us what breaks, telling us what we might still be missing. We're trying not to add too many more new features or make any more API changes, but we're just trying to tighten it up, make sure it's easy to get up and going, and that we're not, there's no big major showstopper bugs. And I wanted to say a huge thanks to the community and all the contributors. It's been fun seeing it go from a pasty to something that has a life of its own. And honestly, I haven't had much time the last few months to work on MERB myself, so Yehuda has kind of taken over as the main head guy, and he's done an awesome job. All the team members have really contributed a lot. So I'd like to just say give them a round of applause here. So MERB stack is going to be training wheels included MERB. This is my dog. He hurt his back, so he had to ride in a little stroller for a little while. But anyway, so the idea being that, MERB is very modular, and there's lots of decisions to make if you're just coming at it from scratch. So we are codifying a number of best practices. We're kind of choosing data mapper and jQuery and making a stack that you can say MERB stack, and you'll be up and running with something that is a full stack like Rails. But you'll be under that will be MERB's all of its modularity, so you still have all the advantages. So that's forthcoming. So now with all that out of the way, I wanted to talk a little bit about a new project I'm working on called Nanite. This is a new way of building kind of scalable backends for web applications, and it integrates well with MERB. The way it works is it uses RabbitMQ, which is an AMQP messaging queuing system, as a communications bus, and it allows you to have, your cluster. Let's see if this pointer works. So you've got your cluster of MERB processes that you would normally run. You've got a RabbitMQ broker, and you've got all these agent or daemon processes, right? And all these daemons can have a number of code functionalities. The MERB processes run a Nanite mapper, which is basically a way for them to know which backends are in the system, which are available. So when one of these things boots up, it says, hey, I've got these classes and these services I offer, and this is my load average. And then that gets published to this exchange, which gets the state replicated to all of your front-end MERB processes, so they know which backends are in the system, what capabilities they have, and what the load average of their box is. So now I can say, web request comes in here, uploads a file. I need to do a bunch of image processing on it, so I can say, hey, who's got the least load right now and can process this image? And I'll know this guy can do that. So then I send a request, I stream the file to him, he takes care of it, and then tells me he's done. So this allows you to add servers and backends at will and remove them, and they ping into the master processes every 30 seconds or whatever you set the ping time to. So if one of these things gets super busy, it will drop out of mapping so you can't get to it, and then when it's done, it'll come back online and be available. Or if you add a new server and you throw a couple daemons on it, those will immediately be available. And it's zero configuration, right? These things just have to have their user and password, and you run them anywhere, and they pop online and show up available in your app. So it's kind of based around RabbitMQ, which is a Erlang messaging bus. It's really fast. It's clusterable. It's got a bunch of nice features. You have exchanges and queues, and you can publish to exchanges and have any number of listeners get those in their queues. Queues can be like transient in memory only. They can be persistent, and you can also do transactions across queued items. So it's basically a message router type of system. I love this piece of software. It's a great piece of software. It's a lot like MERB, right? It's only like 5,000 lines of code in Erlang for this very scalable messaging server. It's really easy to get going, so props to those guys. So this is what a Nanite agent would look like. You just have a class. Say we want to do feed crawling, right? We've got a front-end web app. People submit URLs, and we want the backends to go out and crawl those and parse them and do something with them, right? So we've got a feeds class that inherits from Nanite Actor, and it exposes crawl. So you have to tell it, you can expose this method so people can call it from remotely. And crawl takes a list of URLs, loops over them, and processes them, which I'm just going to elide for now. And if it fails to process an URL, it'll put it in failed. If none of them failed, we'll just return success. If some failed, we'll return failed so we know which ones failed and we can redispatch them or whatever. And then we register this feeds class with our dispatcher. So the way this works is when that agent boots up, it will advertise feeds crawl as its service, and any other methods and classes actors that it has, it will advertise. And it will advertise its load average by default so that you can make dispatches based on load average. So the mappers, these run inside of your MERB app or your Rails application or like on a command line or whatever. And these are like your view into the system. Each of these mappers tracks the state that's advertised by the agents. And then you can do dispatch based on a number of factors, included out of the box or dispatch based on least loaded node, random node, or to send it to all nodes. And then you can easily write your own selectors to figure out what you want to do. Since you have, in each of your MERB processes, you have the state and the status of all these agents in your system, you can easily write selectors to select which agent you want to go to. So if we were to want to call the feeds crawl, right, we've got a list of URLs, and we want to do a request for feeds crawl. We give it the URLs, and we say, give me the least loaded guy to do the work. And we'll get the response back, and this block is called asynchronously later when a response comes back, which could take however long amount of time. So you can, set a block and then do whatever you want with the results coming back, or you could just fire and forget and not wait for results. You could also say, instead of least loaded, you could say, give me a random server, or send this to all of them and have all of them do some processing on it. So the way the least loaded dispatch works is by default, we've got a status proc, which is basically just shells out to uptime, parses out the load average and averages it, and advertises that as a float. So when we want to do dispatch, we can look up the least loaded node based on that. But if you have something else you want to do this dispatch based on, and you have in your agents, there's some other statistics you want to use based on least loaded node, like if you have a queue of jobs pending or some other kind of state you want to track, you just set your own proc and advertise anything that is comparable with the spaceship operator, and whichever one compares the lowest will be selected for least loaded dispatch. So this gives you a lot of flexibility in how you manage this cloud of agents working for you, and it makes it really nice, and it can, it can balance out the load as you add servers based on the least loaded system. So it makes writing these scalable backends that just horizontally scale out very easy. So this is the state that the mappers keep. Wow, it got louder. So the agents, every time they, sorry, I'm about to fall off the stage here with this thing. So the mappers, or the agents have a ping time. You say 30 seconds, or you say 5 seconds, depending on your needs and how often you need updates. And the agents post in a hash. Here's my status, which is the load average, right? Here is the services I offer, and this is the timestamp of when I last pinged in. So each nanite is pinging in, the mapper is keeping track of those, and if it hasn't heard from a certain agent within a set timeout, it removes it from mapping so that it can't be dispatched to until it reports back in again. So basically, the status is where you can stuff anything you want into here by setting that status proc, and then use that to dispatch to your system. So it's pretty flexible. So the system all put together, what it gives us is presence. We know when our agents are online, when they're not, when they're busy. Self-assembly, right? Each agent just needs a user and password, and you can actually use the same user and password for all of them. So they don't need any configuration. You boot them on any server anywhere. They just need to know the address of your RabbitMQ broker, and that's it. They come online, they say, here I am, here's what I can do, here's my load average, and then they're part of the system, and then they can drop offline and be removed from the system. So it doesn't care if things are leaving and joining all the time. It's very easy to scale the stuff. And so dispatch based on this fitness function, it's kind of like it's almost like a genetic algorithm, right? You've got this population of these daemons running, and they're all kind of average. You can set your own fitness function, which lets you select who to go to, and they're all kind of advertising in. So it makes it really easy to take advantage of compute in the cloud by fanning out to as many instances as you want and removing them later, and some very cool stuff. It also supports file streaming. So if a file came into your web app, you could stream it over Nanite to any number of agents. It also supports broadcasting. So say you have 5 servers, upload comes into one, but you need to serve it from all of them. Upload comes into one, you say in your agents that you want to get a copy of the file, you tell them to subscribe to files to this, you say subscribe to files, images, and then I can say broadcast the foo JPEG image, put it at this location at the destination, that's a typo there, and use the images exchange, which is what this one's listening for. And that will stream the file in chunks to the broker. The broker will take care of fanning that out to all the listeners. So it allows you some nice stuff to do with file streaming. It's open up on GitHub. You guys can go play with it if you like. It's a really nice system, I think, for building web apps. And the big takeaway that I've found over the years of running all these applications and building applications, you want your front end to return as soon as possible. So any kind of long unit of work, anything that's going to block that request, you need to push it off. You need to get asynchronous, right? So you need to have a request come in and say, okay, thank you, and then push it out to go do the work. And that's how you build sites that your users will find really responsive and that you can scale easily, because as we all know, you do a long processing job or image processing inside of your mongrels, and it's going to block up that mongrel with a bunch of work until it's done. And so you might get requests back up behind that or whatever. So this is a way to offload that work, let other things handle it, and then get results back. Any questions? I think I'm done here pretty much, but.
Have you used Nanite yet in production?
Not big. He said, have I used Nanite yet in production? And the answer is sort of. Like I'm building an app with it right now that will be in production, but isn't quite yet. But it's pretty stable. It's super fast, and I think it's going to be a cool system. Of course, it's a 0.01 release, so expect it needs some work. But the code is very small and simple, so I think it's going to be a pretty good project. Yeah, so that was my next. So the question was, can I write the MERB worker processes to just be nanite actors instead? And yeah, my idea for that I'll probably hack up this weekend is make it so when I make a request to nanite, can have a MERB process, have a request come in and hands me a rack environment, which is what MERB dispatch is based on, which is basically a hash of all the CGI headers and the post body and the URLs and all that kind of stuff. And instead of dispatching in the master process into MERB by calling its rack app, you make a request on the nanite bus and you put the rack environment in there. And the backends will take that rack environment and call the MERB rack adapter and then return the results back. So you could get an automated load balanced system of that. So yeah, that's definitely something I'm going to be experimenting with.
Getting back to your talk on MERB.
Yep.
You mentioned that one of the problems with Rails is that with so many users, it's difficult to make a lot of changes without breaking everything.
Yep.
Hopefully MERB someday will be incredibly popular as well. I think probably a lot of us anticipate that. So how would you mitigate the same thing happening to MERB?
Well, the architecture is built in a modular way, right? With Rails, it's kind of all or nothing, take it or leave it. If you want to pull out a certain part, you end up pulling out like half the framework, right? If you don't want to use active record or something, and you basically lose all the advantages. But with MERB, each piece is basically self-contained, so they can be updated independently. And we've really focused on making public and private APIs. So instead of, Rails has built this ecosystem where plugins use alias method chain to hook in, since Rails itself uses alias method chain and all these other tricks to hook in. We don't like that at all. We don't have a single alias method chain in the MERB code base. We'd rather change MERB to have public APIs with hooks to hook into certain places rather than forcing people to alias all these things around it. So hopefully we built MERB in a modular way and with enough hooks and enough entry points that we won't run into the same situation as much.
Right. I want to say I think it's a cultural problem. I think it is true that there's a lot of people using Rails and now it's like, oh, we're screwed. But it's also a cultural problem in that Rails encourages people to use every single method in the entire Rails code base as the public API. So you can't really change that. And I think we're doing an experiment in the Ruby. So I don't think anybody has ever in the Ruby community released anything and said, here is the public API, although every other language does it. So I don't really know why that is. But if we do this and people actually listen and try really, really hard to always use the public API and report any case where they can't use the public API, right? I think if we build a culture around that, we'll have probably not no problem. We may eventually run into this, but we should have significantly less problem than Rails.
Anybody else? All right. Well, thank you. Thanks for coming to the first MERB camp. It's pretty cool. Thanks, guys.